Hello, so continuing on problems from weekly contest 348, the second problem is semi-ordered permutations. So what this problem says is that we have we have a permutation of n integers, and then we have this definition of a semi-ordered permutation where it's just if the first number is 1 and the last number is n, and n being just the number of integers we have, okay? And you can do this operation that we define here any number of times until you make the array semi-ordered permutation. And so again, how do we make an array semi-ordered permutation? Well, we need 1 as the first index and n as at the last index, okay? And what's the operation we are allowed to do here? Well, it's just picking 2 adjacent elements in the array. So let's say 1 and 4, and then swapping them. So putting 4 here and 1 here, right? So that's what we are asked to do. So this is the operation we can do. And what's the goal? Well, the goal here is just to return the minimum number of operations that we need so that we can make it semi-ordered. Semi-ordered, just the definition here. 1 at the first index and then n at the last index. And so if we take a look here, what we want to return is the actual number of the operations. And so here, what can we do? Well, first we can swap 1 and 2, right? And then that way we'll end up with like this. And then we swap 4 and 3, we'll end up with 1, 2, 3, 4. And now we have 1 in the first index and 4 in the last index. And 4 is the number of elements, so 4 is n. Okay? And so how many operations did we need to do here? Just 2. And you can try you can try all variants you want. This is going to be the minimum possible. For this one, we can just swap these 2. Okay, so we'd have 2, 1, 4, 3, and then swap again these 2, right? 2 and 1 will end up with 1, 2, 4, 3, and then swap 3 and 4, and we are done. And this is 3 operations. Okay, so that's sort of the idea here. Now, the length of the numbers is not too big. Okay, so let's see how we can tackle it. Okay, so how do we handle this? Well, the first option is really easy, which is basically if the index of 1, right? So if the index of 1 is smaller than the index of n, then the problem is easy because, let's put it here, then what we need to do is just calculate how many operations it will take to put 1 at the first position, and then how many operations it will take to put n in the last position. And so here, how many it is it's just the index itself, right? Because it's just the index. So let's call index of 1. Let's have this variable called index of 1, where we can just take, just get from the array, we can just get the index of the value 1. Okay? And so for getting 1 to the front, it's just going to take index of 1. And then for getting n to the front, it's just going to take, how many is this? Well, this is just n. Let's suppose you had like n, and then how many elements you have here. Then how many is this? Right? Well, this is just the length of the array minus the index of n here minus 1, right? That's because each time you'll do an iteration, and that's just the distance here minus 1. And so this is just, length is just n minus the index of the value n minus 1. And so this is what will take to get this to the front, and this is what will take to get this to the end. And so it's going to be the index of 1 plus this. And so this is the result that we need to return. Okay? Now, the only thing we need to think about, does this apply in all cases? Well, the first case is 1 is before n. The other case is n is before 1. And so let's see how would that other case be impacted. And so the other case is having the, let's use the example that we have in the problem, which is 2, 4, 1, 3. Okay? And so here you can see we have 0, 1, 2, 3. So the index of 1 is 2, and the index of n is 1. So you can see the index of 1 is bigger than the index of n. So if we go by this formula, what changes. So if we go by this formula, then we get the result is going to be just the index of 1, which is 2, plus the index plus n, which is 4, minus the index of n, which is 1, minus 1, which is going to be 2 plus 2, which is 4. But this is wrong, because if you look at this, what we can do is first just swap 1 and 4, so we get 2, 1, 4, 3, and then swap 1 and 2, we get 2, 4, 3, and then swap 4 and 3, we'll get 1, 2, 3, 4, and we are done. We have n at the end and 1 in the front. And how many did we need to do? 1, 2, 3, just 3. So this is wrong. But why? So this is wrong just if the index of n is before the index of 1. So how do we fix it? Well, you can see here what happened. The thing that happened is that because we swapped 1 and 4, 4 just advanced by 1 position. Okay? And so it's not actually this only, it's this minus 1, because while moving 1 to the front, we advanced n by 1 position. And no matter what is happening, let's say if you had 2, maybe something like let's say 4, 3, 1, moving 1 will still advance 4 just by 1 position. It will never advance it by more than 1 position, because if you look here, what will happen is that you'd have 2, 4, 1, 3, because we swap these, and then we would do 2, 1, 4, 3, and so you can see what did 1 to do to 4. It just moved it by 1 position. It will only move it by 1 position. And so because 1 takes care of that 1 position for us, we just need to subtract another additional 1. And so let's call this here diff, right? Then our result is just going to change by one small thing. So if the index of n is before the index of 1, then we just need to subtract 1 from the overall difference, or let's call this count. Actually, that would be better variable name. So then we can just need to subtract by minus 1. Why? Because moving 1 to the front would make n move just by 1 position, because it's before it. We will have to swap it with it once, which will make it just push it to the right by 1 position. And so we don't need to do that push as part of this, as part of moving n to the end. Okay, and so that's the only thing we need to do, and then at the end we can just return count. I hope that made sense. And so basically what this means is if the index of 1 is before the index of n, then we can just return the calculation here, which is just the sum of moving 1 to the front and moving n to the back. And then the other, however, if n occurred before 1, then moving 1 to the front will make 4 push to the right by 1, and so we just need to subtract that from our overall count, because we don't need to do it, right? And that's pretty much it, and we can return count. Okay, I hope that's clear. Now let's code it up and make sure it passes. Okay, so let's code this solution. So first we need to get the index of each one of them. So first we need to index of 1, which is going to be just nums and index of 1. And then we need the index of n, and we need to also just define n, which is going to be the length of the numbers. And now we initialize our count. As we said, it's going to be the index of 1 plus n minus the index of n minus 1. So this is how much it will take to move n to the back, and this is how much it will take to move 1 to the front. And then we need to handle the special case if the index of n is smaller than index of 1, then 1 will move n 1 position to the right, and so we just need to remove that, because to remove it from this part here, and so we just subtract 1, and then we can return count. Okay, so let's run this and let's submit, and this passes. Okay, now the index here is going to be O of n, and so overall we have O of n time, and space, since now we are not using an extra space, is going to be O of 1 space. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.